Rolling.
Welcome everybody to this new Tezos meeting in Barcelona. Today I'd like to talk about how to bake on Tezos. I'm Pietro Abate from Nomadic Labs. First of all, I would like to give a small introduction of what is Tezos, the Tezos timeline. Tezos it's a project that started quite a long time ago in 2013 when the first white paper was published anonymously on Reddit, and it was basically a way to provide a solution to a few flaws that we saw in Bitcoin and Ethereum. And our solution was to be able to do self-amendment of the blockchain protocol with a non-vote with a vote on the chain. Between 2014 and 2017, we worked to build a prototype and raise funds, and finally in 2017 we created the Tezos Foundation. This foundation, it's the organization that holds the funds, and it's responsible for the development of the Tezos ecosystem. Finally, in 2018, we proposed the first testnet for Tezos that we ran for about 4 months before launching the Tezos mainnet. We wanted first to experiment and to propose to the community the first amendment, and so in May 2018, the 8th amendment was proposed by Nomadic Club. This was the first amendment that was ever proposed on a blockchain, and the community reacted very well. The amendment went through, and after that we had the other 2 amendments. That is the Babylon proposal that was proposed by Cryptium Lab, that it's a Swiss company, and Nomadic Labs, with the help from the legal community. Recently we proposed a 3rd amendment, that is the Carthage amendment, and this is going to be voted soon by the community. And again, this was proposed by Nomadic Labs with the help of Cryptium Labs. The Tezos ecosystem, it's as a blockchain, a decentralized network of entities. Now, on one side, there is the Tezos Foundation that helped the technology, that helped the development of the technology of the ecosystem. Then there are a lot of companies that do development on the Tezos blockchain. Namely, there is Nomadic Club, that it's a French company that works in conjunction with the Tezos on the Tezos technology. And it works in conjunction with Nomadic Clubs, Lambda, TZQ in the US. These are all independent companies that are funded via grants by the Tezos Foundation, and they work for the development of the Tezos network. We also provide a lot of grants. The Tezos Foundation provides grants for create tooling around Tezos, and they are generally all open source, and the applications are open to all companies and individuals that are willing to work on this network. There is also a big effort to promote a community around this blockchain, and namely there are the Tezos Commons in the US, the Tezos Southeast Asia, and the Tezos Ukraine, to give you, for example, that are working in this country for the promotion of Tezos. And of course, last but not least, we have a lot of research partnership to work on the fundamental advancement in blockchain technology. We work with INRIA in France and with INDEA in Spain, to name 2 big research entities, and we are just promoting fundamental research in blockchain technology, related but not completely tied to Tezos. The Tezos Foundation in particular helps the advancement of the Tezos technology and the growth of the Tezos ecosystem. It focuses at this time on three main axes. One is the tools and applications, so it's the development of tools and applications to support the Tezos ecosystem. The second one, it's about the community organization, and the third one, it's about education. And using these 3 axes is is providing grants to different communities to help with the Tezos network. Now I would like to talk a bit about the basics of a blockchain, and then go specifically in the details of what means to be a baker and what means to bake on Tezos. Blockchains are often called crypto ledgers. That it's a metaphor to think about one of these accountant books that were used in the past to record the transactions. Now we maintain these metaphors, but the transaction on the blockchain have one important characteristics that are immutable, that cannot be changed. The other important characteristic is that they are shared among all the participants in the network, so the transactions are not stored centrally, but are decentralized in this network of nodes that store this ledger. The generic algorithm that runs the blockchain is actually very easy. There are a number of nodes that receive these transactions to all other participants on the network. This network in particular, it's a peer-to-peer network or a gossip network. At a certain point in time, in Tezos, this happens every minute. There is a node that is entitled to aggregate a number of transactions and to create a new node. This operation is called baking, and today we are going to look how this selection is done and what this operation entails. Once a block is baked, a block is created, then this is broadcast by the node that created on the network, and other nodes are using the consensus algorithm are going to accept and verify that this block contains valid transaction, that it's a valid block, and add it on the blockchain. So what is baking? Well, baking is an operation that, as I explained it before, it just consists of collecting transactions that were injected on the network. These transactions are just simple operations to send tokens from one identity to another, but can be composed by also other different type of transactions and create a block. But this is not as easy as it seems. For example, in Bitcoin, this operation of baking is called mining, and this collection of transaction and the signature of this collection of transaction, it's bounded to an algorithm, a puzzle that can be solved by a node, and the first node that solves it has the right to inject this block on the network. In Tezos, this is a bit different, as we don't use the same algorithm, but we use what is called the proof of stake algorithm. So in Tezos, at each round, we randomly select for each block one baker. Then this baker has the right to select to create the next block. On top of this, there is also another operation that we call endorsing. So at each block, we also randomly select 32 endorsers. Endorsers are also made by bakers. So bakers kind of have the two way of participating into the network. One is by creating the blocks, and one is by verifying that blocks that are created by other bakers are actually valid. And once and each endorser verifies that the block is valid, and send his endorsement associated to this block. So if you look at this picture, we can see that at each point in time, each minute, there are a number of identity that are these TZ identities that are associated to different priorities. If everything goes well and the identity at priorities 1 is able to create a new block and to bake this block, then this is injected on the network. as I said, there are also, once this block is injected on the network, there are also a number of endorsers that are selected to verify that this block is a valid block. And so there are 32 of these endorsers that can stamp this block. Stamp means digitally sign this block to approve that this block is actually valid, and inject their endorsement on the network. Clearly, if the baker at priority 0 for some reason, for example, it's disconnected at that moment, or there is an hardware problem, or the software isn't running correctly, is not able to create a block, then the baker at priority 1 can take over, and he has kind of the right at priority 1 to create this block, and so forth. In this process, since one block is created. This process of having multiple priorities associated to each block ensure the liveness of the blockchain, and ensure that the blockchain cannot be stuck because there are no baker running at that moment. Of course, the blockchain works on kind of game theoretical principles of rewards and incentives and punishments on the other side. So the incentives associated to bake a block, to participate to the creation of a new block, and so to the health of the Tezos network. The network provides some token incentives. So for each block baked, each baker will receive 16 Tezos, and for each block endorsed, each endorser will receive 2 Tezos. Of course, associated to rewards, there are also disincentives, or if we want to call them punishment. These are to make sure that all the participants will be good actors in this algorithm, and being a good actor is more rewarding, is more convenient than being a bad actor. So when a baker earned the right to bake, he can get 16 Tezos as a reward, but he also has to freeze, to kind of commit 512 Tezos on the network as a security deposit. This security deposit is going to be held by the network and then given back to the baker at the end of the cycle. If the baker did a good job, so he participated in the algorithm correctly, he will receive back the 16 Tezos plus the 512 Tezos. If there was a problem, there was a violation of the protocol, like double endorsement or double baking, then this security deposit will be slashed by the network, and the endorser will lose the 512 Tezos. The baker will lose the 512 Tezos. Similarly, for endorser, there are a gain of 2 Tezos, but the deposit is 64 Tezos. So as I said, there are 2 main reasons why an endorser or a baker can lose their deposit. One is double baking, so there are 2 blocks that are baked at the same height. This is to disallow to spend tokens in twice, for example. And at the same time, you cannot endorse twice the same block at the same position. This is because there is only one valid block at the top of the chain, and an endorser cannot vote for 2 blocks at the same time. To ensure that these rules are respected, there is a third daemon that runs constantly on the network that is called the accuser, and it checks the network for the occurrence of these two situations. And if this is the case, he injects an operations on the network to denounce this situation. Here I want to give a couple of bit of an explanation of what happens if when a baker is baking. So if one of the main problems while starting baking is to realize that we need to have some liquidity associated to the tokens that we have committed to the baking algorithm. If there is not enough liquidity associated to this token, then the baker simply can't bake. The algorithm will deny the right to bake to a baker that doesn't have, for example, 512 tokens available to be frozen. And in this case, the baker with the next priority will take over. In case of endorsement, there is not takeover, so there is no second priority. It is simply the slot for that endorsement slot that was going to be empty. So how much liquidity do we need associated to the amount of token that we have devoted for the baking algorithm? In theory, there is a formula that gives the number of 8.25% of the tokens related to the algorithm. So if we bake, if we have one roll, that it's 8,000 Tezos, that is the minimum amount of tokens that we need on our account to bake, then we need at least 8.25% of these 8,000 tokens available. In practice, because of the economics of the network, and since not everybody's baking on the network, nowadays this number it's more about 10% of the amount of tokens delegated to the baker. So for 8,000 tokens, we need about 850 tokens of liquidity to be able to bake during the 5 cycles without ever losing a slot. If we have less than this 10%, this is known as over delegation. It means that we have more token delegated to us, that we have more baking slots than the baking slots that we can actually use, because we don't have enough liquidity to freeze our funds during the operation. So here there is a simple overview of baking in Tezos, and as I said, it's not as easy because before I kind of didn't talk about all the technical points about randomness. Randomness in Tezos, it's very important point, and this is how these bakers and endorsers are selected during the process. So the algorithm starts with a commitment of a seed to be revealed at the cycle n minus 7. These commitments are basically cryptographically encrypted random numbers that are committed to that are stored on the network, and these are going to be used to generate a random seed that is going to be used to generate the list of bakers that are going to be selected for baking. So at the cycle n minus 7, we put this encrypted numbers. At cycle n minus 2, we take a snapshot of this encrypted number. At cycle n, we reveal these numbers and we create this seed. With this seed, we can decide the next the baking rights for the next 5 cycles. When we arrive at cycles n plus 5, we can imagine that we can start baking from that cycle, and then only at cycle n plus 11 we can see the rewards that we earn during the last 5 cycles deposited on our account, together with all the rewards that all the security deposit that we have done in order to bake this. So these systems can seem extremely long, and actually this is another point that a lot of new bakers are a bit puzzled. Why, when I start to bake, I'm not baking immediately? This is a consequence of this system, because when I start to bake, I basically start at cycle n-7, and I can only I will only have my priority assigned and cycle n plus 5 at cycle n. This is to ensure the fairness of the random algorithm, and to ensure also that this cannot be gamed by evil actors that, by modifying the randomness of the selection, can influence, can get more baking slots than what they should be, than what they should have. So now I'm going to talk a bit about personal tutorial, a personal baking tutorial. I'm going to talk about how to install the Tezos client, how to understand the official Docker images that we're going to use all over this demonstration. And I'm also going to use the test tool, that it's a custom orchestrator for Tezos images that we develop at Nomadic Labs. So first of all, I want to stress that when we deploy, when we use Tezos, we should not compile from source. Compiling from source is recommended only for development, but not for deployment. This involves learning how to use OCaml, nearly how to deal with the changing the dependencies of our project, and also somehow to follow the ongoing deployment. This is when you deploy a node for baking. Shouldn't be a concern, and by using our Docker images, you should be available to bake without taking care of all these details. The tools and requirements for this demonstration is Debian machine or a VM, Docker, Python 3, and Snap. The requirement of a Debian machine is mainly because we use Snap as a binary distribution for our client, but otherwise our Docker images runs also on Mac OS 6 and Windows, so there is no restriction about this. The hardware specs about to run the baker are not that constraining. An SSD disk is essential, because baking it's a time-constrained process. So having a disk that can give us reliable access to the data, it's very important. However, baking is not CPU-bounded operation. We don't need a really fast machine. And memory-wise, the node will consume about 4-6 megabytes of RAM on average, and this should allow us to bake also on small machines. There are reports that of people even baking on Raspberry Pi Model 5, Model 4 that are small machine with 4 gigabyte of RAM. All of these say that we don't need a fast and expensive machine to run Tezos, and Nomadic Labs and in other companies who are working to make it possible to bake even on smaller machines. To install the Tezos client, we use Snap today. Snap, it's a container-based software distribution platform. You can get the binary that we prepared for this demonstration at the following website. It's a banner that is prepared by me, and I'm in the process to upload it on the Snapcraft official website in the next month. To install it, we need to have sudo access, and we need to specify the ---- dangerous option, because for the moment the binary is not cryptographically signed. Finally, when the binary is installed, we can just tell the system where to find it, and we can use directly, for example, asking the manual. The Tezos client can be used for multiple, on one end to talk to the node, and on the other hand to as a wallet. So for example, if we ask the Tezos client if the node that is connected to its bootstrap, that it means that is synchronized with the network, we can just use the command Tezos client bootstrap, and it will give us the head of the blockchain at this moment. Or if we have an account named Bob, we can ask simply the balance by using the command Tezos client get balance for Bob. Tezos client try to use more the kind of natural language type of command line to make it easy for user to remember it. The Tezos client has a number of global options that can be set. This can be set, for example, with the config init. Bypassing the -a of -a, we can specify the IP address of the node that we want to connect it to. In this case, RPC alpha tz beta.net, it's a public node. We can specify the port, that is 443 in this case, and the encryption algorithm, that is HTTPS with -TLS. Now we're going to talk a bit about the public Docker images. This comes in two flavors, and we use Docker images since the beginning of the project, and they are slowly getting better and better, and we are now consolidate on three images. There are the Tezos image, that it's an image that comes by default with an entry point. This is an entry point to run a number of commands, and I will show you this in a moment. This entry point, it's a simple shell script. This is done basically to make it easier to use these images. Then we have the Tezos debug image, that it's the same one that is compiled with the debug symbols. This is mostly used for debugging operations, and in particular related to performance. And the third one is the Tezos bear image, that has no entry point and gives direct access to the Tezos binaries. These images are constantly up to date created and kept updated by our GitLab CI, and they are not versioned yet, so there is no latest image, but they are tagged. So there are a few tags. One is mainnet, one is master, one is zeronet, one is Babylonet. If we want to look a bit deeper in these images, we can use, first we can pull an image from the Docker repository, and then we can inspect the labels associated to this image. Here we can see that there are a number of labels telling us the type of system that we are running, a few other informations, including the GitLab repository. There are two important labels that I want to stress about. In particular, it's the build ref and the VCS refs. These are very important for debugging, as they identify the base build image that this image was built from. This means all the dependencies associated to build this image, and also the commit on our Git repository to specifically pinpoint the commit that this image was built from. And these are very important informations when reporting a bug on our issue tracker. Run a Docker image is actually easy with Docker. As I said, this is the Tezos master, so the label here it's master, and since this is the image using an entry point, This is the help of the shell script that I was mentioning a moment ago. Yeah, a moment ago. The shell script can run some daemons, and in particular the Tezos node, the Tezos baker, or the Tezos endorser. When running, for example, the Tezos node, the image is going to also to automatically initialize a new identity for this node. But the entry point has also the possibility to run some clients. So you can run the Tezos client as before, but also the Tezos signer and the Tezos admin client that I'm going to talk in a moment. And we also have the possibility to run a few other commands that are one-shot commands. For example, to upgrade the storage or to import a snapshot. This command in particular is the one that we're going to talk in a moment, as it makes much faster to initialize a node than syncing the node from the network from scratch. So if we want to run a Tezos node, we can simply issue this command. This command will create a new identity automatically and run a mainnet node, since we didn't specify anything else, in full mode, and you will start the bootstrap process. Since here we didn't specify anything, the bootstrap process will take about 5 days to sync. It's going to take about 40 gigabytes of storage. And during the bootstrap process, you can take up to 8 gigabytes of RAM. However, after this time, the node will use steadily more or less 4 gigabytes of RAM. But this is a long time, and for this reason, we implemented a system of snapshots. Snapshots are just a copy of the network archive that can be imported by the node in a faster way, and to allow to sync with the rest of the network in matters of hours. For example, to download the recent snapshot, you can go to this website. This website, it's a repository of snapshots that it's administered by a Nomadic Club team. And in particular here we are downloading a Babylonet snapshot. This is one of our test networks, and we're going to play on our test networks today to give you the possibility to experiment also on baking on Tezos, but without actually having to commit any Tezos for it. This is a great playground, and I invite you everybody to try it on. So after we download the snapshot, we can just run this command that basically looks a bit complicated, but it's only saying to bind the file that is named full to the file that is named snapshot inside the virtual machine, and then runs the Tezos snapshot import command. Once this is done, the node has now a partial idea of what the chain looks like. I can connect to all the bootstrap nodes to sync with the chain. The integrity of the chain is cryptographically ensured, so there is no way to cheat in this process. Something that we have to specify, since we are running a different network, is the ---- network option, and now we specify Babylonet as the type of network. These options only work for the moment on the Tezos master Docker image, but soon the other images will also have this option. now for the moment we have run all these comments using Docker, but since we didn't specify any volume, all the data was stored inside the Docker overlay. This Docker overlay, it's a really fragile way to store informations, as Docker images are meant to be updated and recycled, and when this is done, all this information can be lost. To solve this problem, we should create what is called a Docker volume, that it's a space that it's handled by Docker, but it's not going to be removed at every update. So we need first to create a Docker volume, and then to associate this Docker volume to the directory var run Tezos, where all the informations inside the image are stored. When we do this, after importing again the node, finally we have a node that it's now synced, and all the data it's now saved and stored reliably. But of course, running our node with Docker, even if it's possible, and I think it's important to understand that this is how it works, is not what we recommend. We have created a test tool that it's a custom orchestrator for a Docker image that try to hide all these details from the final user. So installing test tool is is pretty easy. You just need to copy this long command line that is saying nothing else to run this Docker image that is called test tool latest. Test tool is also Docker image that runs other Docker image, and as such as it needs to access the Docker daemon via a socket. This is why we have to provide these informations to the daemon. Once this is done, test tool can be used in a really simple way. For example, to start a node and sing it from scratch, we can just run test tool, the name of the network, for example, Babylonet, and giving the command start. This will run a container and expose the RPC port to localhost. But if you want to expose your port to the world, you can also do by specifying the command --RPC port. This is usually not recommended, as the RPC port not only gives access to your node, but also to some important configuration options of your node. Starting a node from a snapshot, it's equally easy, since if you tried just a moment ago to run that command, again you started to sync a node from scratch. Now we can simply undo what we started to do with the command Tezos Babylonet remove, then purge all the volumes and all the informations that were stored in Docker volumes, and now we can start again to import a snapshot. Now all the informations related to Docker volumes and low-level options are hidden from the user. So to import a snapshot, we just need to specify Tezos tool Babylonet snapshot import and the name of the snapshot that we downloaded. And finally, to start a node, we can simply specify test tool Babylonet start, the name of the port that we want to use, and the type of history mode that we want to use. Tezos test tool also allow to do simple operations on a node, like stop and start of the node in a simple and safe manner. It allows us to delete containers, to purge all the data in the container. Sometimes this is needed to clean up a broken installation, for example, or in other situation of where we want to test with a new network. So now we change a bit of topic, and we're going to talk about wallets, how the Tezos client manage our keys, and now it can be used as a command line wallet. So to create an identity on Tezos, we can just specify the command Tezos client gen keys Bob. Bob, it's just a name that is local to our computer. It's going to be associated to a public key and to a public secret key schema that are going to be stored on our computer. These gen key comments can take a few options. One, it's the type of signature that we want to use, and the other one, if we want to have the type encrypted on disk. This is the default for the moment. So if we want to create a type for Bob, here we are specifying the type of signature that by default it's the elliptic screen 25519. And when we want to look at the key that was generated for Bob, we can just use the command Tezos client show address Bob, that is going to give us the public hash of the public key and the public key. And if we want, it can give us also the secret key of this identity. Of course, by default, we don't show the secret key, and the secret key it should be kept confidential at all times. In this example, I want to notice that the hash that starts with the TZ1 it's a type of identifier that we're going to see multiple times in Tezos, and actually we have seen it also before. And this is the identifier that we use to exchange token on Tezos. This is what this is called an implicit account. The name Bob it's exists only on your machine. Everybody can be called Bob, and everybody can be called Bob. So a number of files that are stored on our machine when we create an account. These are the public key hashes, the public keys, and of course the secret keys. This is the directory that you have to make sure to backup. The secret key in particular are very important, as if they are stolen, anybody can take control of this account. These files are simple JSON files that are not binary files, and in this configuration they are only stored encrypted on disk. But in general, the Tezos client can use other schema to store this information, either in an hardware wallet or on a remote machine. Now, if we want to start playing on Babylonet, we can get some free Tez, for example, to bake on Babylonet. So we can go to the website faucet.tzalpha.net, get some tokens, and we can import some tokens in the wallet. This is done by using again the Tezos client, activating the account Alice with Faucet. Faucet.json is the file that we downloaded from the Faucet website. And once we imported this account that contains the public key, the hash, and the secret key for this account Alice, we can look at the network, and we can look how many tokens are associated to this account that we call the Alice. So at this point we have created two accounts, one for Bob, one for Alice, and Alice has some tokens associated to it. Bob is going to be our baker account, and Alice is going to be our personal account. The first thing that we can do to start a baker is to use test tool, issuing the command test tool babylonet baker start. This is going to start a baker, but for the moment it's not going to bake because there is no account associated to this baker. We can also, in this context, interact with the baker using the Tezos Babylonet client commands. So, for example, if we want to import a secret key to the baker, we can use the Tezos Babylonet client import secret key, and here we can give an alias, and we can also give, for example, assigning schema. For testing purposes, this can be directly an encrypted secret key that we can use for baking, or it can be a more complicated schema, like asking the baker to query a remote signer for all the signing operation. This will allow us to maintain all our keys in a different space from the baker. So if the baker is for some reason compromised, our keys are not going to be compromised as well. We can also check for the logs of the baker issuing the command Tezos Babylonet baker logs, and this is going to give us all the low-level logs for this baker. So, as I said, there are two types of account. There are the TZ types that are called implicit accounts. They are implicit as they are created on our machine, and they are made explicit. They are revealed only with the first transfer on the network. When we want to start baking, we need to register one of our account as delegate. An account can be a delegate of himself, or it can be a delegate for other accounts. In this case, we can use the Tezos client command, Tezos client register key Bob as delegate, and this will just transform this account, register this account as a delegate. So once we have registered an account as a delegate, we can also set Bob as a delegate for Alice. So as I said, we had an account Bob, that it's our baker account, and we have Alice, that it's our personal account. By setting Bob as delegate for Alice, we create an originated account on a network of type KT that is going to hold this information for us about the delegation. After the delegation, we can delegate some funds to Bob just by transferring some tokens to him. As a moment ago, I talked about the signer. I think this is an important point about baking. So on one end, we can imagine to have a Tezos node and a baker and endorser running on the cloud. And on the other side, we want to keep our secret keys in a safe place. We can imagine in our home or on a different cloud service, for example, in one of these HSM modules. So for this reason, there is this idea of remote signer. The remote signer is yet another command that we can run. This comes together with the snap package that we installed a moment ago. So to run a signer, we can just generate some key for the signer, and then we can launch the signer with the command Tezos signer launch HTTP signer. So at this point, the signer is going to have the credential for Bob, that it's our baker account, and is going to be able to respond to signing requests for these accounts. This means that when Bob is going to have the right to bake by the chain, and the baker is going to collect the transaction to create a new block. He's going to ask the remote signer to sign this block for the baker. This means that he's going to send the data stream of bytes to the signer, asking to sign these informations. The signer is going to use the secret key that is stored on the hardware wallet, for example, on the signer's side, and then sending back to the baker only the signature for the block. This means that in this configuration, the secret key never leaves the signer hardware wallet, and it's never transmitted anywhere to the baker and endorser. The Tezos node, the baker and endorser, can disappear anytime from the network, and this is not going to compromise again the secret key. So, as a simple recap, to bake, we set up, we register Bob as a delegate, then we set Bob as a delegate for Alice, and then we configure the signer to run with the Bob's credential and to communicate with our baker. One important question is when is my turn to bake? This is said. It's important to understand when starting baking on mainnet. There are multiple ways of knowing when it's going to be my turn. One is to use the Tezos client and to look at the to do an RPC request. We can also, for example, get the bakers at priority 0 for cycle X. If we want a more visual way of accessing this, we can just use on TZ on a website like tzstat.com, and there we all have these informations aggregated for us with a very nice visual representation. So I would like to spend a few words why this is all complicated. Well, first of all, it's security. The point of having a baker and a remote signer is because your private key should never leave your machine. It should be really well protected. The signer should be configured using an hardware wallet like Ledger. Ledger, it's a company that has been working for us for quite a while, and their hardware wallet has been proved quite reliably while baking. Baking should be kind of easy, but not too easy at the same time, because it requires to have a bit of technical understanding of the network to run a baker. And also, if we become a baker service, or we accept that other people will delegate their token to us, we need to provide some kind of reliability to these people that entrusted their tokens to us. We develop this system with Tezos tool because we think that baking should be a mostly automatic system, and a system that we can improve together. And in particular, we want to use these Docker images as they should be easy to update, and they should require no compilation or no technical knowledge of the tool chain of Tezos. Can we do even more complicated? Of course, yes. There are professional bakers that have multiple front-end nodes to have 99% uptime. The goal is never to lose any baking slot for any technical problems. Another way to make it more complicated is if you have many roles, is to split your roles among multiple bakers and delegates. This will give you some form of redundancy and kind of to minimize the possibility of losing a baking slot. But you can also be much less complicated, and this means to delegate your roles to a professional baking service that is already doing this work for you. The downside is that, of course, this baking service, they will ask for a small fee in order to administer your Tezos. So here I want to point a lot of these slides were taken from an very nice article from Baking, and this is on published. This has been published on Medium in 2019. There are also a couple of nice tools that are used by bakers to redistribute their rewards. These are nice to look at if you want to understand how they work and how the system is implemented. And last but not least, there are all the technical documentation that is on our GitLab.io repository that I invite you to look at. And there are a lot of information about baking. Thank you very much for your attention, and I hope this tutorial has been helpful to you.